This is Professor Rogers. In this video, I'm going to show you how to use the RegressIt add-in for Microsoft Excel. We use RegressIt when we're doing an ordinary least squares using a data set that's set up as an Excel spreadsheet. A question you might ask is, why do I need an add-in? It's a fair question to add because Excel does have some regression capabilities within its statistical formulae and also in the analysis tool pack. However, there are two issues. One, many people find doing regression in Excel a bit cumbersome. Second, Excel does not give us all the statistics that we might want. In particular, it does not give us the standardized beta coefficient, which is used to determine the effect of an individual parameter on the dependent variable. RegressIt is easy to get. It's free of charge, and all what we have to do is find it on the web. So what I will do here is go to my browser, Google, but you should be able to find this in any browser, and I'll type in a single word, RegressIt. RegressIt, and hit return. It's at the top of my search results. I think that's probably going to be true with whatever browser you use. It will be at or near the top. The reason is there aren't many things in the world called RegressIt spelled with one word. Now, you might not get this secondary tier of results. So what I'll do is I'll just go right to the home page so that you can see how easy it is to find these other secondary tiers. So here I'm on the RegressIt homepage. You'll see this menu at the top with various options. We want to click right here on free download. You'll see there's a RegressIt for PC and a RegressIt for Mac. If you do not use RegressIt Logistic. If you are a Mac user, you might want to double check the directions to make sure that what I'm saying with the PC also works. Occasionally, there are some differences with Mac. Okay, I'm doing the PC because I'm in the Windows environment. So here we have a page full of directions. They might seem a little foreign to you if you're not used to working with stats, packages, or adding various software pieces. The thing we really need is right here in the middle, where it says installation and testing. We have two files here, regressitpc.xlam or a zip file. Now, I realize sometimes there are very good reasons to download a zip file, but most of us should be able to do this using the regressitpc.xlam. So you can click on it and it will automatically download, or in my case, I want to control the download, so I will right click on it. So we'll go save link as, and you'll see here, mine went into a folder called RegressIt because I had been experimenting with this. A lot will depend on your default folder. For many of you, it will go either to the download folder or the documents folder or your OneDrive, depending on what the default is. It could, as in my case, go to your last used folder. Now, part of the reason why I have a special folder is I have lots of different softwares. These are like small, many of them are freewares or very cheap. So I put my RegressIt in here. So here is my folder that I created for it. You don't have to be as fancy as me, but here I go, and I'll just save it. Now let's go over to the file directory. There I have in my quick access, I have my software folders, and then here is my RegressIt. Here it is. Now, the RegressIt add-in will call in all of Excel. So just by clicking this, we can get Excel, but we have to do one thing first, and that is we have to unblock it. I'll right-click on the add-in, go down to Properties, And in properties, in the property box, there is this thing here that says unblock. So it's blocked right now. And this is a security defense. Although we do have Windows Defender and it is working to protect us, here's an additional layer of defense, which says don't open this file unless it's unblocked. Leave it, wants Defender to block it. And so it's, again, it's an additional layer of defense to keep bad things from falling onto your computer. But this is not a bad thing, so we will unblock it. Click OK. Now I will open the RegressIt PC add-in. So here we go. Now I get this dialog box. This is, it looks scary. Microsoft Excel security notice. Again, it's saying that this could be a security concern, but this is because it's an unrecognized package. You just click the enable macros. Everything will be fine. If you know that this happens a lot, if you know the package, it's okay to use. It's just not one that people use a lot. So we'll just enable the macro. Now we get the Excel spreadsheet. You will see that here, but notice we have this additional piece. We have RegressIt now as part of our Excel spreadsheet. So the next thing I do is to bring in my file. So we have to go out and find it on the web. Oh, in our files. Oh, I don't have to look very far because it looks like I've recently used it, like 13 minutes ago when I was testing this. So we'll just click there. Load it like we always do, and here we see our class data set. There's one more thing I have to do before I can use this, and that is I have to name the variables. So when we were using Microsoft Excel and the data analysis package and we did some things, you recall we had to check label, and then it knew that the first row was the label for the variable. We have to do something similar here with create name. So I'll highlight my data set. And then I will go here to RegressIt. And it says, so in the RegressIt menu, there's this thing here that says create names. So with the data set highlighted, I will click on that. And it has already checked two boxes. It's checked the top row or the left column. And it says, I think it's kind of guessing where the names are. It says, I think the names are either in the top row or in the left column. They're in the top row, so I'm going to turn off the left column. And then we'll click OK. And now we're ready to go. So right here in the RegressIt menu is the linear regression. So we'll click on that box. And here's what we get. You'll see here here's the names of the variables that we just recently assigned. First thing we want to do is we want to select our dependent variable. So I am going to try to predict the violent crime rate, which we have been doing this term. And I'm going to predict it. I'm going to use the poverty variable. So we're going to use the poverty rate to predict the violent crime rate. What we would expect as a hypothesis is that as the poverty rate goes up, the violent crime rate will also go up. So we can actually test that hypothesis with a regression line. I'm going to, by default, it's going to give us the regression analysis. I am going to add one thing to it right over here on the right, the line fit plot. That's for a simple regression. Now, a simple regression is when we have only one independent variable in our model. We can have more than one independent variable in our model, but right now we have only one. And so I am going to click on this, and that will allow us to see the scatter plot with the regression line on it. So I'll run this. And here are our results. You'll see it sets it up as a separate page here in my spreadsheet. Just like we were doing in Excel, it's a separate sheet. So I'll start here. This is the part that's not default for regression. This is a scatter plot. And so on the x-axis is the poverty rate, and on the y-axis is the violent crime rate. And so what we're doing is we're using a line, and we're saying at what point, at what level of poverty do we predict a certain level of the violent crime rate. So that's a line. That's just the basic line that you learned about back grade school or middle school or high school, wherever you had that, whenever you had that course and it was introduced to you. This is the equation of a line. And so here is that line. It's this red, dark red line running through the middle. That is the regression line. So when we use the poverty rate to predict the violent crime rate, this is the line that tells us what that prediction is. The less dense red lines are the upper and lower rates of the confidence interval. So the line does have a confidence interval. Because the mean is used as part of the regression equation, then these lines, that has a confidence interval. So there could be different lines going through here. So we have a 95% confidence interval, but having that 95% confidence interval allows us to do the typical hypothesis testing that we've been doing throughout the course. Our main results are up here. So that's the thing. This is the thing that we really want to look at. Our hypothesis testing is in this lower part of this table up here. So first, let's talk about the constant. The constant really doesn't have a theoretical interest to us, but it is part of the regression line. So the constant's another term for the y-intercept. So this line, if the poverty rate were 0, the point, that line would extend out to having a y value of 57. So that's our y-intercept, 57. If there is no crime, the violent crime rate is 57. Again, that's not really part of our hypothesis test. Now, our hypothesis is being tested down here in this second line. This is the coefficient for the poverty rate. So let's look at this closely. Here is our slope. This is 28.55. The slope of this line is 28. So what do we know? Well, first off, we have a direction, right? This direction is positive. If it were negative, we have a minus sign in front of it. So the direction of this relationship is positive, which means as the poverty rate goes up, the violent crime rate also goes up. Now, we haven't determined yet whether this is statistically significant result, but we're moving in that direction. This coefficient itself means that the violent crime rate will go up 28.55 for every % increase in poverty. Every increase in the poverty rate, this will go up 28.55. That's the rise over the run, as it is sometimes called, of the change in the dependent variable over the change in the independent variable. You had all of that back before you took stats. The question is, now we should be bringing out, cleaning out cobwebs, right? That's what it was before. Now, the thing, of course, that's different is when you were doing this back in school and picking the equation of a line, the points would fall perfectly on the line. You recall, for every if you had 2 points on a line, you could then run the line right through it. Well, with this line, that's not the case. So we're going to talk about this in a moment, about how this is different. Over here in this column is the p-value, and that has the statistical significance. Remember that the standard hypothesis test is that something is statistically significant if p is less than 0.05. So look at this. This is 0.001. That is way less than 0.05. So the fact that that number's small does not mean it's less significant. It means it's more significant. It is highly significant. And then we have the confidence interval for that line. So when we're looking at this lower rate and this higher rate, we're seeing that, if the slope is 28.55, at the low end, of our estimate, it could be 12.456, and at the high end, it's 44.644. So we think in terms of confidence, we are 95% certain that the slope of the line falls between these two values. And then let's take a look over here at this number. Now, this standardized coefficient is an important number, and that's why we are using the RegressIt package, because this is the thing that gives us the magnitude or effect size of this relationship. The standardized coefficient is 0.454. Now, this has a direction. It's positive or negative. It will have the same direction as the slope of the line over here. But obviously, by standardizing it, it's going to have something different. Standardized coefficients range between +1 and -1, so we can interpret them just the same way we would interpret a Pearson's R. So remember the breaks for Pearson's R, we took the absolute value and our breaks were 0.1 for weak, 0.3 for moderate, and 0.5 for strong. So this is a 0.454. It's just below a strong relationship. It's a moderate relationship, but you know, it's just a hairbreadth short of being a strong relationship. So looking at that, we conclude that there is a positive relationship between the poverty rate and the violent crime rate, and that it is a strong positive relationship. Now we get something else up here, which is the fit of the model. And this goes into this issue that our points don't line up on the line. You see, we have some that are far away and some that are close. So what we want to make sure is that this is moderately close. We don't expect the points to line up perfectly on the line. That just doesn't happen in the real world. So here we're looking at this statistic called R squared. That R squared is 0.206. You can multiply it by 100. It means that we're explaining 20.6% of the variance around the dependent variable. Now you're going to say, wow, 100%, you only did 20.6%. But, you know, hey, remember batting averages. Batting averages aren't that high either. 20.6%, to interpret that, you take the square root of that number, and you can use the Pearson's R rule for interpreting this. As it turns out, in the simple regression case, it will be in the simple case, the square root of the R squared is going to be the same as the standardized coefficient. Now, let me just run one more regression for you. I'm going to add the variable population. I'm not going to add the variable percent black because that would give away the answers for the class. But I'm going to add the variable for population. I'm going to turn off the line fit plot because it's not going to work in this case. When I have two or more independent variables, I have what's called multiple regression. And what happens is the presence of one variable controls for the other one. So let's now run this. Here I get a second model. You notice on my sheet it says model 2. And what it does is it looks at, gives us these results here. Now, one of the things that we get is here is the relationships here with one variable controlling for the other. So the effect, you know, poverty rate is now influenced by the presence of population in there, or we're saying it's controlled for the presence of population. Similarly, any effect of the poverty rate is controlled for by the, any effect of population is controlled for by the presence of poverty. So one of the things we can see is, does the presence of population, if you are in a large state, does that influence the relationship between poverty and violent crime rate? And we see here not much. I'll just jump right over to the standardized beta coefficient. Poverty, this is 0.4456 here, which is just a smidgen bigger than poverty. But what we would say is it's just so close. I'd say that this doesn't change much. In fact, in assignments, I would not even tell you to look at that third place to the right of the decimal point. And we can figure out pretty quick why that is. Take a look here. The p-value is 0.801. What that is telling us is that poverty is not statistically significant. And over here with the standardized beta coefficient for, I'm sorry, population is not statistically significant. And over here, when we're looking at the standardized beta coefficient, this minus 0.33, that's almost zero. You know, that is a non-existent relationship. Even though it's got a minus sign in it, don't say this is a negative relationship. This relationship is almost zero, doesn't really exist. But what happens is that now the R squared becomes its own entity. If poverty was also influencing this in any great way, we would see the R squared then substantively depart from what we saw before. We don't see it here, but that's what happens. Okay, this will give you a really good start for working on regression this week in my classes, and I hope you do really well with this. All right, that's it, and I am going to now turn off Blackboard.